Oh, okay, yeah. Well, we obviously still need to cut out. We need to cut out a circle because the contribution. Because the fall off goes on forever, right? So it goes on past the first box, or even past the second box, or past the 10th box. So we still have to cut out a little. We still have to cut away the glow past a certain point, and so let me see here. Let's just get back to. Let's just set the offset to 0 for a second, so all of them are at the same. Yeah, and like in order to show you properly, damn. Okay, let me just do this here for 1 second. Comma 1. Let's just get rid of all of that. So now we have all of our stars in the middle, and there's 9 of them on top of each other. That's why they're so bright. So let me divide this by 9. Okay, so there are the original stars. Yeah, we still need to cut out the glow. So over here, let me just go times equals, and if I put the box back here, the box is back. We can have a quick look. Let's just get rid of that. Okay, so there's the box. So we're just going to make it that this glow is faded out at the edge of this box here. And so for that, I could just do times smooth step, and then I can use the same distance that we calculated here. So the distance, and then we can say it needs to be completely faded out at 0.5 distance, and it needs to start fading out at, let's say, 0.2. So that will fade that out like that. And so now if I go back here, and I go back to where we were, like that, let's see. Okay, so now we have a bunch of stars that are properly, that go properly across borders, basically. So that's pretty cool. And now we have an added benefit, which is that, like before, we could only, we had to fade this out over the length of 0.5, right? Because if this thing is in the middle, it has to fade out over the length of 0.5 to be done at the edge. But now that we take the neighbors into account, we can go a bit farther. Because let's say this one's at the edge here. This one has to fade out over a distance of 1 in order, because it can go into the neighbor, it just cannot go into the neighbor's neighbor. All right, so now like we can fade out all the way to 1, and that makes a lot nicer glow if you just check here. So now you have a lot smoother glow. All right, so there we have a bunch of stars. Okay, so now I want to do a few more things here, which is, let me just take this here and say float star equals that. And then we can just do col plus equals star, so that doesn't change anything. Because I want to add a few different things. I want them to have different sizes, first of all. So for that, I'm going to do float size equals. Oh yeah, and so like to get a different size, you just multiply it, right? So if I multiply this by 2, then I get a brighter star. Or if I multiply this by 0.1, then I get a fainter star. So I can get a random number again based on that technique that I said before. So we just take that n and we multiply it by a number that is a lot larger now than the other one over here, right? Because we don't want to get something that is very similar to the other one. And so this again is a random number between 0 and 1. So now I'm going to have random sized stars. So that's pretty cool. And now I want this flare only to be on the largest stars. So let me just cut this out and put it before here. Because we can turn the flare off, right? Like, because we had this as a separate parameter. So if this is set to 0, then I don't have any flares. So now what I could do is I could say, in order to only have it on the largest stars, I could use a smooth step, and then I could say, I could throw size into there, and then I could say 0.9 and 1. let's say. So now this smooth step is going to return 0. When size is smaller than 0.9, it's always going to return 0. And it's only going to go, and then after 1, it's only going to return 1. But between 0.9 and 1, it's going to kind of step up. And so now you will only have that flare on the largest star you see over there, for instance. So maybe this, if I zoom out a little bit, I could see a few more stars to see how many flares there actually are. Yeah, okay, so maybe this is a bit too conservative because there's only like kind of a half flare over there. So let's just change this a little bit to include more stars. Okay, so now I have it on a bunch of them. And you can obviously play around with this to your heart's content, you know, until there is something that you like. All right, so now we have that. So now the next thing is we want some different colors for this star. And so to get a color, I just multiply this by a color. So I could multiply it by, let's say, some bluish color over there. And now I have a bunch of blue stars. But I want random colors for each of them. So I'm just going to cut this. I'm going to say color. And then here I'm going to make my color. So color equals that, let's say. So that wouldn't change anything. And now how do I get random colors? Well, I could use a sine wave for that. So if I stick this thing into a sine, so in shading languages, you can throw a vector into a lot of different functions, including a sine. And what that does is it just does the sine 3 times. So this will just return a vector 3 within in the x component the sine of 0.2, and the y component the sine of 0.3, and then the z component the sine of 0.9. And if I multiply this, let's say by I time, so what this will do now is it will do 3 numbers at the same time that increase at different rates, and then it does the sine of that. And so a sine returns a number between -1 and 1, and a color is a number that has an x, y, z between 0 and 1. So I have to get it into that range. So if I multiply by 0.5, now my sine is going to go from -0.5 to 0.5, and if I add 0.5, now it's between 0 and 1. So that gives me a color that slowly fades with time. Okay. Now I don't want that. I want a color that is different for each star, and so we need a number that's different for each star. And so for that, again, I can make a random number from my first random number that I had. So I can multiply it this time by something in the thousands. So I don't know, something like that. Let's see. Okay. Yeah, and then the other thing is that I need to multiply it by a larger number, because right now I'm just playing around in only part of the phase of the sine. So like a sine is a phase of 2 pi, and this number is a lot smaller than 2 pi. So that's why you don't see much color variation. So you would have to multiply this by at least 2 pi in order to get the full color. The full color spectrum. And these colors kind of suck. Why is that? Okay, well, like I said, at least 2 pi, but I guess I need to do it larger. Yeah, because these numbers are smaller too, so it kind of makes sense to make this larger. So this could be any number as long as it's the smallest part here can get larger than 2 pi, then you should be fine, I guess. So yeah, we could multiply it by any kind of larger number to get more different colors. All right, so I'm going to shape this color stuff a little bit more because I don't like confetti colored stars. So I'm going to do color plus equals, no, color equals color times, and I can filter this. I can take out the green. I don't like green stars, so I can filter the green by just multiplying by, if I multiply by this, then it just will multiply the red by 1, the green by 0, and the blue by 1. So that will just take out all the green. But let's not take out all the green. Let's take out 0.5 times the green. And then let's also, I don't know, let's make it that, and I'm not a cosmologist or a cosmologist. So I don't know, but I have a feeling that larger stars are bluer. So I'm just gonna add blue to the, so if I add my size to this, then for bigger stars, it just adds a bigger number here. So that should add a bit of blue. I have to add a decimal point here if I do that. So that just makes the bigger stars bluer. Yeah. Well, anyways, again, like you can tweak this to your heart's content to get exactly the star colors that you want. I'm going to leave it at this in the interest of time. So, okay, so now we have a layer of stars. And so now what I'm going to do is I'm going to cut this entire thing that we created here and cut it out, and now I'm going to make a function and I call it star layer. So star layer, and there we go. Stick that whole thing in there, and I'm just going to return the color. So return col, and as an input, that star layer is going to get the UV, obviously. So vec2 UV. And now I can just go over here and I can say col, well, I have to go here, col equals vec3. Let's initialize it to black and then get rid of that as well. And then say col plus equals star layer of my UV, let's say. Okay, that didn't change anything, so that tells me it works. And so now what we could do is we're going to make a bunch of these layers. So I'm going to go for float I equals 0, I is smaller than or equals 1. Actually, smaller than 1 is fine. And then I plus equals 1 divided by a number of layers that we're going to have. So you could write this differently with an integer and then calculate stuff inside of the loop, but I kind of like it like this because now my I value goes from 0 to 1 inside of the loop. And 0, 1 numbers are kind of easier to turn into any number that you want. So I have this num layers over here that I have to define over here. So let's just go over here, say define num layers, and let's set it to 6. And now inside of here, so now if I do this, it's going to run everything 6 times. So my stars are going to get 6 times as bright. And obviously we want different values for each of these layers, right? So the first thing is I want those stars to start out small, and then as they get closer to the camera, they get larger. And so for that, I could just multiply this here by some larger number to make them smaller. And so what I can do here is I can multiply this by some value, call it scale. And then over here I could say float scale equals something, a mix between values. So like all the way in the back, let's say we want it to be let's say 20, and all the way in the front we want to say 0.5, and then we're just going to throw that I value into it to see. All right, so that does that. I'm just going to take this UV times 5 out here to kind of zoom in a little bit. And let's just make a few less layers so we can see what we're doing here. So let's say 4 layers instead. And now let's move these layers. In order to move them, I can just add time to this I value here. But if I do that, so t, and then let me just define that over here. So float t equals I time times 0.1, let's say, so it doesn't go too fast. And then let me just reset this here. So go back, and now you see it moves, and that's great. But then you get this stuff where it moves backwards, and that's because this can get out of range now, and then you kind of get this screw up. We want this I plus t never to get above 1. When it gets to 1, it needs to snap back to 0. And for that, I'm going to make a variable, and I call it depth. So depth equals the fractional component of this. So now what depth will do, depth will be a value that increases with time, And it also, with every layer, every layer has a different value of this. But when it gets out of the 0, 1 range, it snaps back. So let's say it goes from 0 to 1. As soon as it reaches 1, it goes back to 0. So now what you get is you get a bunch of layers where if one layer hits 1, it gets back to the back of the line, and then this one gets back to the line. And so now we have something where if a layer gets too far to the front, it snaps back to the back. All right. So that is already pretty cool. And so now we obviously don't want this pop to happen. And in order to hide that, we can just make it that, because if we multiply this by some smaller value, then we can make it darker, right? And so what we want is just multiply this by some value fade that is 0 all the way in the back, right? So I can do float fade equals, well, one value that's 0 all the way in the back is the depth value, right? So I can just multiply by depth. And so now I have it that in the back, you don't see that pop anymore. It just kind of slowly fades in. All right, so that is pretty cool. Now let's move, because right now every star layer is positioned exactly the same way. So that's why you see this star repeating each time, right? So the star just keeps coming back. And to get rid of that, what we can do is we could just add some value to this, because if I add something to this, then it just shifts the layer over a little bit, you see? And so we can use this value I, which is different for every layer, right? I is different for every layer. And so now it will shift every layer a little bit. But we want to shift it by a lot, because right now you can still see the star being repeated. But if you multiply this by some larger number, now you look at a completely different part of every layer. And so now you have that. So now let me just put back 6 layers. All right, and let's also move a little bit slower. Okay, so there we have that. All right, so now let's see here. I don't like the flare too much on a lot of them, so let me just maybe move that a little bit back to where I had it originally, maybe. Also, we could just attenuate the entire flare by multiplying that by some smaller number to get it a bit softer. Anyways, that's all tweaking stuff. Okay, let's add a rotation to this. Oh yeah, also you see sometimes you see the layers pop out because we made it that it fades in the beginning, but it can still pop out in the end, because this thing goes from 0 to 1, and then it just goes straight to 1, and boom, it goes back to 0. But at the end, we also want to fade that out, so we could just use a smooth step for that. And we can say, well, if I do this, 0.9 and 1, and then depth. So now my smooth step here will return 0 if my depth is smaller than 0.9, and then only at 0.9 it will go to 1. But I want the opposite. I want it to be 1 when it's smaller than 0.9, and then fade out in the end, right? So for that, I could just turn these numbers around. Okay, and now you will not get that pop out anymore. It will just fade out. And you will only see it when you're close to a star, but anyways. All right, so let's make this thing rotate. So we just go over here and say UV times equals rot of T. Okay, so now we have it slowly rotating, this entire thing. And let's see here. How many layers do we have? Let's stick some more layers in there. Well, maybe not that many. 8. Okay, fine. And then what we could do is we could add the mouse to this. So here, MichaelFK mouse equals. I could just do the same thing as what I did for the UV. So iMouse.xy minus I resolution.xy times 0.5, and then we have to divide that by I resolution.y. It's exactly the same thing. So now I have a mouse that goes from minus to 0 to a plus somewhere. And now I could use that to add to my UV coordinate. So plus equals m, and let's see what that does. And so now we can kind of look around a little bit, even though this is completely 2D. So let me just multiply that by some larger number. Let's say 4. We're still moving quite fast. I don't like how fast we're moving. Let's go slower. Okay. All right, so now we can look straight ahead, or we can look to the side. And we can't look back because it isn't 3D. This is still just 2D trickery. But yeah. All right. One last thing that I could do. Oh yeah, okay, so another thing you could do, so you could add it over here and then you can get this looking around effect. You could also, if I take it out there, you could add it over here inside of my star layer, so plus M, and then you have a slightly different effect because then you get like this parallax effect, and actually you just have to do minus M, I guess, to get it. Well, anyways, you can kind of screw around with that, but so that could be cool as well. Or you could add both. Fuck it, why not add both? And so, yeah, you get some 3D-ness to this. Okay, last little thing here. It would be cool to kind of make these things sparkle a little bit. So, so what I'm going to do here is I'm going to do star times equals the sign of something, and again I want it in the 0, 1 range, so I just do that again. And then if I just multiply this by, say, I times, let's say 3, then it would just fade all of them in and out at the same time. But obviously I don't want that. I want it per star, so I could just use my n value, and again, like before, you need to multiply it by the entire phase of the sign, so 2831, or a larger number could also be. And so now you get a different fade for every star. So you get a little bit of twinkle to this. And you know, it doesn't have to twinkle all the way to 0. It could twinkle like maybe make it like this, so it twinkles to 50% brightness. No, that's about it. Let me just let's see, let me multiply this by smaller because I don't like the green in here. Yeah, this is cooler. Yeah, that's pretty much it. Yeah, I hope you like this, and I hope you you make something cool with this. And if you do, please please show it on the Facebook group. I would love to see what you guys make with this. And oh yeah, there's another thing. I added a like a link to just give me a tip if you want. So if you feel like you know, you can't really become a patron and support all of my videos, if this video is worth $1 to you, then you can click on the link in the description and throw it over to me. That would be great. And yeah, there were also some people that started doing subtitles in different languages. So my hexagons video was done in Russian. So thank you very much for that. If anyone else wants to translate a video that they like into their language of choice, then please drop me a line, and I'll help you out with that. Yeah, anyways, I hope to see you next time.